Hello everyone. Hope all that is going well with you. This video we're going to look at functions as equations and function notation. So we're going to determine whether a given equation is a function, and we'll look at what it means for an equation to be in function notation and how to evaluate uh, functions that are in function notation. Okay. All right, so first of all, let's look at a few definitions. We have an equation is a function if there is only one resulting y value for each x value. Now this is pretty similar to that definition of a function where we said that each element in our domain is paired with only exactly one element in the range. So for each x value it gives us only one y value. Now, one method to determine if a function is if an equation is a function is to solve that equation for y and then test one or two values to see how many solutions you get out. And then finally, function notation. That's basically replacing, if we have y equals x squared plus 2, that's basically replacing that y with what we call f of x, and it's shown by f parentheses x. But again, that's called f of x. F of x. And that f could be different letters. It could be g parentheses x or g of x. So that f variable could vary, could be different. Doesn't necessarily have to be f. Okay, so let's take a look at an example or two to determine whether an equation is a function. So we have the equation of x squared plus y equals 16. So again, one method that we can use to determine whether an equation is a function is to solve the equation for y. So here, since we have x squared plus y equals 16, we will subtract x squared from both sides. So that gives us y equals 16 minus x squared. Y equals 16 minus x squared by subtracting x squared from both sides of the equation. So now we could pick a value, any value, let x equal a particular number, and then plug it in, substitute in, and see how many solutions we get out for y. So if we let x equal 1, for example, we would substitute 1 in the place of x. That would give us y equals 16 minus 1 squared. We know 1 squared is 1, so 16 minus 1 would be 15. And that's only giving us one solution. So that's saying when x is equal to 1, then we only get the solution of 15 out of that, the value of 15 out of it. So for every x value, we're getting one y result. Therefore, this equation is a function. So this equation, it represents a function because we get one resulting y value for every x value that we plug in. Now to determine, let's look at another example of determining whether an equation is a function. Let's say that we have x squared plus y squared equals 16. So again, to start this problem out, to solve it for y, we would subtract x squared from each side. And we don't want y squared, we just want y. So in order to do that, we want to undo the square by taking the square root of each side. Now remember, when you take the square root of that right hand side over there, you have to consider the positive and negative value. So the square root of y squared equals positive negative square root of 16 minus x squared. So the square root and the exponent square, they would just undo each other. And we would end up with y equals positive negative 16 square root of 16 minus x squared. So let's again let x equal 1. Now it could be equal to any other number, but let's just let it x equal to 1 and plug 1 in the place of x squared. So since we have the positive negative, that's going to give us two separate equations. So we have y equals the square root of 16 minus 1 squared, or we have y equals negative square root of 16 minus 1 squared. And since we have two separate equations, once we plug that in, again 1 squared is 1, 16 minus 1 is 15, we would end up with two separate solutions for the one value that we plugged in for x. So since that x value produces two different solutions, this is not a function. Since it produces more than one solution, this equation does not represent a function. As a matter of fact, if you were to graph this, you would see that, I know this is not going to be a perfect circle, but you would see that this equation represents a circle, and if you remember the vertical line test says that if you draw a vertical line through the graph and it touches more than one point on that graph, then it's not a function. So there you can see that this equation does not represent a function. Okay, let's evaluate functions with given values. So let's say we have the function f of x equals x squared plus 2x minus 10, and please note that this is what we call function notation, where we have the f parentheses x. F of x equals x squared plus 2x minus 10, and they want us to find the value for f of 3. Well, basically all you are doing is substituting and simplifying. So we will take that 3 and substitute in for every x variable that we see in this function. So f of 3 would equal 3 squared plus 2 times 3 minus 10. And then from there, you're just simply using your order of operations on the right hand side to simplify that, keeping the f parentheses 3 like it is on the left hand side. So 3 squared is 9, 2 times 3 is 6, and you have f of 3 equals 9 plus 6 minus 10. Calculate that, and f of 3 equals 5, and you're done. So you're substituting what's in parentheses in the place of the variable, and then you're simplifying. Okay, let's look at another example. So f of x equals x squared plus 2x minus 10. Find f of x plus 2. So again, everywhere that I have an x in my original function there, I'm going to replace it with x plus 2. So x squared becomes x plus 2 squared. 2 times x becomes 2 times x plus 2. Now we have to multiply this out, and remember that if we have a plus b squared, that's equal to a squared plus 2ab plus b squared. So that will give us x squared plus 2x. Sorry about that. 4x plus 4 plus 2x plus 4 minus 10. And that will give us f of x plus 2 equals x squared. Combine the like terms. 4x and 2x is 6x. 4 minus 10. 8 minus 10 is negative 2. So f of x plus 2 would equal x squared plus 6x minus 2. Okay, I hope that you found this video to be helpful. Thank you. See you on the next one.